So now let us continue. So sixth question we have solved just now. Six questions is over. Let us go for the upcoming question. Question number 7. Okay. So question number 7. You can see question number 7. Let me read that. Okay. So question number 7. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta, comes to rest if the total time elapsed is t, then maximum velocity. So they are asking a question without giving any numerical values, just by taking some notations like alpha, beta. So what is alpha, beta here? We are taking alpha, beta to represent accelerations. Okay. So now what we are supposed to do? So let us solve question number 7. So question number 7, what is that? A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. That means I will take similar diagram, A to B, then C. Car accelerates here from A to B from rest. That means initial velocity equal to 0. Sorry, alpha it is. Till beta. Thereafter next what happens? It starts decelerating. Decelerating. That means from here it is decelerating means what is the sign I am supposed to take? That is minus beta, which represents the deceleration. If total time elapsed is t, then maximum velocity attained is total time. I can take this one as t1 and this one as t2. So total time t is equal to t1 plus t2, like this I can take. And now what I do? You can see there initial velocity is 0. So let me just take the common. Okay, here one condition is there. One case, second case. First case accelerating, second case decelerating. So basic equations I will put. Final velocity is what? Final velocity is v. V equal to u plus at. What is u? Plus at. That means plus alpha t. So v is equal to alpha t, or alpha equal to what? V by t. So this is what the equation I am getting. Next question is, from B to C what we are having the case, that is deceleration. Deceleration, of course, finally the velocity should be 0, because final velocity I can write down here, that is v equal to 0. And now final velocity 0, so I am going for, this is first case, that is A to B. Next, B to C case, let me check. So what is here now? Final velocity 0. That is why v equal to u plus at. So u is how much? For B to C, already the body was with the velocity v when it reaches here. So that is why initial velocity becomes v here. That is why this is v here. Then plus at. What is the acceleration here? Minus beta. That is why minus beta t. So what I can write here? So v is equal to beta t we can write. So finally what is that? So beta is equal to v by t. But now you can see there time I have taken slightly different. Here this interval t1, this interval t2. So t1, t2 like this. So you can frame it as the equation. So now what you can write is, there you can check beta equal to what, alpha equal to what. But what we require here, we require the condition or clue they have given is total time taken is like this. So I will write this one as t1 is equal to what? T1 is equal to v by alpha. T2 equal to what? That is v by beta. Now we will add, what is that? T is equal to v by alpha plus v by beta. So once you substitute these, you are supposed to get the answer. What is that? That is alpha into, yes, what is that we are supposed to get? If the total time elapsed is t, the maximum velocity attained is, that means you have to get the value for v. So soon after substitutions, taking the LCM and all, how it will become? So this becomes t is equal to what? That is beta into v plus alpha into v divided by alpha beta, common is v here, so v is equal to what? V will be equal to, finally I will write the answer here. You are supposed to get v is equal to alpha beta t divided by what? Divided by alpha plus beta. Whether it is correct, check the options. The option is option A. I think it is clear for you people. That is question number 7. So question number 7, there is no directly given values. You can see the board. There is no directly values which is mentioned. What we are supposed to do, we have to take it as an assumption. What is it? Alpha and beta means what? Alpha and beta means they are just the notations. They will represent what? Accelerations. So they represent acceleration. We just use some of the basic concepts here. These are substitutions of these numericals look slightly complicated because too much of mathematical steps, but have a close look here. This is not difficult. This is easy. Next question. Okay, this is kind of interesting one. You can see the question says, question number 8, okay? Question number 8. Question number 8. A train starting from rest accelerates. Train starting from rest equal to 0. Accelerates uniformly for 100 seconds. Accelerates uniformly for 100 seconds, okay? Thereafter, then it comes to stop with the uniform retardation of in the next 200 seconds. So train starts, accelerates uniformly and decelerates in the next 200 seconds. Initially acceleration takes place for how much time? That is 100 seconds. What about deceleration? Deceleration takes place for next 200 seconds. What's the total time taken then? 100 again plus 200. That is total 300 seconds. The total time of movement of the train has taken place. Next, what is there? During the motion, it covers a distance of 3 km. So total distance traveled. 3 km means how much? 3000 meter. Total time taken is how much? That is 300 seconds. You might be familiar with the VT graphs or graphs in the concept of one-dimensional motion. What I do, I will just apply the knowledge of graph in this particular question, okay? I will draw a VT graph, velocity versus time graph, okay? Train accelerates. Slope of VT graph gives you acceleration, right? That is why? Yes. Train accelerates uniformly for how much time? 100 seconds. Decelerates for how much? Next, how much is that? Next is the next extra it has taken how much? 200. That's why you can, by writing 200 here, that means it becomes here 100 again 200 means this becomes lengthier interval. But I am writing directly the last interval here. I am not writing again separately 200. After 100 again 200. That means here it becomes 300 then, correct? So time taken, you can see velocity, whether we know with what velocity it was moving, increase in velocity, decrease in velocity. We don't have any idea about that. Okay. But we can find out change in velocity. Okay. So question number, yes, of course. Now what we do, let us substitute that one. So next, what are the substitutions we can do here is, you can see it is actually a triangle, right? So what is area of VT graph? Area under VT graph gives you what? Gives you displacement. Am I right? Now what I do, individually I will find out what? Find out the area. Okay, whether you know this V value, we don't know. This value is of course. Now first case, I will take this one as area 1, this one as area 2. So area 1 plus area 2 should be equal to what? Total distance travelled. I think you can understand this. So what is area 1? I'll do it here, okay? Area 1, it's a right angle triangle, right, almost. So half into base into height. Height is what? V. We don't know how much is that. So it is 50V plus what is A2? A2 equal to half into base. I'll take here. It is 100 to 300. That means already how much is that? 100 it is mentioned there. From 100 to 300. Next 200, 300. That means here how much? Here value is 200. So don't write here 300 because from 100 to next it is. So next into what is the velocity? Velocity V. Next. After that, how much is the value here? So this becomes 100V is equal to total distance travelled. It's mentioned in the question itself. How much is that? 3000. Correct? So total how much? So 150V is equal to 3000. So V is equal to how much? 20 meter per second. Now what we are supposed to find out here? We are supposed to find out, choose the wrong option. Choose the wrong option means what is it you are supposed to find out? That means one of the option is wrong here. Which one? The maximum. Okay, let me check. Okay, what is that? Now you got what? Now you got the value of velocity. So distance travelled you know already. Initial velocity you know. Time you know. You can find out what is the value of acceleration as well. If you substitute there, okay, the acceleration value will be 0.2, its retardation value will be 0.1. How to get that? You can just substitute in any of the case. Just put the value either V equal to U plus AT formula, or you can use S equal to, just check, okay, UT plus half AT square, or you can go for V square equal to U square plus 2AS. You have to find, that means find which of the equation will be suitable. Here we don't have any knowledge about what is that auxiliary, that means time. That is why first two equations are correct equations, but our case it is not suitable. So we can just use this particular equation. So V square here, what is the velocity V square here? That means can take whatever the options. I will just go for the second case here. Final velocity is 0 square, 0 equal to, what is the initial velocity? Initial velocity, of course, we will be checking U square. Initial velocity will be this one now, 20 meter per second. 2 into A into S. Distance travelled is 3000. Just you can do the substitutions, okay. I will just directly write down the values. So those values will be, it's a basic equation, substitutions. So acceleration A1, that means acceleration is 0. The options it will be like acceleration 0.2 meter per second square. Next, deceleration A2 will be 0.1 meter per second square. These are the two values you are going to get soon after finding the velocity. I think till here it is clear for you people, and this one you just apply for okay, that particular equation of motion and just find out that. You will be getting acceleration is 0.2 meter per second square and deceleration is 0.1 meter per second square. Now let us check out of these four options which is wrong. First one is correct, second one is correct, third one correct, fourth one is wrong. So option D is the correct answer for being wrong out of the options. I think it is clear for you people. Question number 8 is over. Now let us continue for the next question. And the next question is, let us see. Question says, question number 9. So I read the question. The ratio of distance through which a ball falls in the second and third and fourth second is, the initial velocity of the ball is 0. So it is like a free fall. So distance traveled in different interval they have given. So distance traveled in nth second, what is the formula actually? Sn equal to ut plus half a into 2n minus 1. It's dropped from rest. It's a free fall, correct? It's mentioned at the last. Value of the initial velocity of the ball is 0. That means Sn is equal to what? Half into a into 2n minus 1. What else they have mentioned there? They have mentioned what? You have to find out the ratio of second, third and fourth second. So nth second, yes, of course. Let us find out. I will go for first. What is that? That is second. S2. And how much is that? Half into a. A means g. 2 into 2 minus 1. How much you get? 4. That means 3g by 2 I will get. Next, third second you are supposed to find. S3 I will take. So half into g into 2 into 3 minus 1. That becomes how much? 6. That means 5g by 2 we will get. Next, for the fourth second, S4 equal to half into g into 2 into 4 minus 1. So answer is 7g by 2. By looking at the equation number 1, equation number 2, equation number 3. If you compare all this, the ratios are S1 is to S2 is to S3 is to S4 is equal to 3 is to 5 is to 7. And the correct option is option A. So option A is the correct answer. So that is about question number 9. So let us continue to the next one. Question number 10. I read the question. Question number 10 says, a stone falls freely from rest from a height h and it travels a distance 9h by 25 in the last second. The value of h is, stone falls freely from rest from a height h. It travels a distance of 9h by 25 in the last second it is mentioned. Something almost similar to that of, distance traveled in n second, the same concept. Now what I do, I will take the question number 10. Simply I will take the general formula for that. Distance traveled equal to half gt square. Why it is so? Because object dropped under gravity. That means sign conventions you must be knowing. Next, at last what it has done? 9h by 25. Last second. Distance travelled in n second. That is 9h by 25 equal to half into g into 2 into n. N is what? Whether they are mentioned? No. Last it is mentioned simply. So 2t minus 1 I will take. Now what we can do from these two equations? You can compare these two equations by taking equation number 1, equation number 2. So finally, what you get is, by equating these two, what and all things get cancelled, you can check there. And by solving these two equations, equation 1 and equation 2, you are supposed to get, by solving equation 1 and equation 2, you are supposed to get time t is equal to, do the, that means calculation part, you have to get the answer. T is equal to 5 seconds and h is equal to 125 meter. But in the options, whether both are there? No, only h value it is mentioned. So they require h value. So h value we can say it is 125 meter. So 9th over, 10th question is also over. Let us go for the question number 11. Hope 10th question is clear for you people. So question number 11. Question number 11, you can see the velocity time graph of a body moving in a straight line is shown in the figure. The displacement and distance traveled by the body in 6 seconds are. Graph is given, okay. This graph looks very simple, but be careful while substituting, okay. Like this. What we require here, the total displacement and distance traveled by the body in 6 seconds. So this is VT graph, it is given velocity, time. Displacement and distance, both they require now. So first let us go for displacement. Displacement means it is direction dependent. Here direction is positive way, negative way, positive way. So area under VT graph has to give you what? Total distance traveled. So what is the area of this? So first I will go for displacement is equal to here 4 into 2, that means 8, negative direction minus 2 into 2, that means minus 4, next 2 into 2, 4. So displacement is how much? 8 meter. Correct? Displacement means direction dependent. That is why there it becomes 8 meter. What about distance traveled? Let us see. Distance traveled. Again check this one. So area 8. But distance means it is path dependent, not direction dependent. So whether the body goes in reverse direction also, it will get added up. So 8 plus 4 plus 4. Answer is 16 meter. So answers are what and all? 8 meter and 16 meter. So those are the answers for which one? For the question number 11. It's a graph oriented kind of question. Next. Question number 12. Question number 12 says, it's also graph oriented kind of this one, numerical. Graph is like this, sharp down and up like this, and again it has continued like this. Next here value they have mentioned, how much is that? It is 2, here it is 1, here it is 2, and this is 8, this is 10, and in between 6, 4, 2. And which one? This is also velocity versus time graph. So what they require here in this question, VT graph of a body moving in a straight line given below, the displacement of the body in 10 seconds. That means entire area you are supposed to find out. Displacement they have asked, no. So displacement, direction dependent. That is why first calculate this area, add this area, that means A1, this area A2, A3, A4. That means displacement S equal to what? A1 plus A2. This one is negative coordinates, minus A3 plus A4. So your final answer should be 6 meter. Check. It's like a previous question. Direct one. Fine. Next question. And the question is, a particle starts from rest at t is equal to 0 and moves in a straight line with the acceleration as shown below. So you can see there, acceleration versus time graph they have mentioned. Okay, AT graph it is, not VT graph. So be careful. So AT graph like this. what they have mentioned here, plus 3, here minus 3, the value here is 2, this is 4, 1, this is 3. Okay, AT graph, it is acceleration versus time. A particle starts from rest, t is equal to 0, moves along a straight line, acceleration as shown below. The velocity of the particle at a t is equal to 3 seconds, they have asked. T equal to 3 seconds, you are supposed to find out. You can see t equal to 3 seconds. That means here what's happening? First area, that means area under AT graph gives you velocity. Okay. So here only till here. So how much is that area? Let us see. So now you can see at time equal to 3 seconds, that means initially how much it is? That is V0 I will take, okay? That means V0. Initially how much velocity it was? So initially starting from rest means, of course, initial velocity should be 0. So I will go for what? I will go for the next one. That means final velocity V3. V3 means this one, A1. This is in the negative direction. Acceleration means vector quantity. This is area A2. Only this much area, because till 3 seconds it is mentioned. So by mistake, suppose you calculate for entire one means you will go wrong. So the wrong option also it will be there in the options. That is why. So here 1 into 3. Next 3 and here 2. That means 3 into 2 is a rectangle, almost a square. Okay. Minus this one 1 into minus 3. Of course you have to add. So finally what happens? It becomes minus 3. So 3 meter. Therefore what they are asking there? They are asking what is the velocity, right? The velocity of that. Final velocity minus initial velocity. How much is that? Therefore velocity V is equal to V3 minus V0. How much is that? 3 minus 0. Answer is 3 meter per second. That is the option. Question number 13 is, option is 3 meter per second is the answer.